sample of uraninite,
Oh, yeah.
a sample of uraninite or pitch blende, and the the radiation from that, as far as I can tell, is only alpha and beta, and obviously alpha is going to be blocked by, I've got 20 centimeters, so that's going to be blocked by air, the plastic, and everything. But the beta, I don't think there's any, as far as I know, I don't think there's any gamma in the decay chain for
Yeah,
uranium.
yeah, there's gamma. Yeah,
Oh, yeah.
there's daughters in there. You know,
Okay.
and even pure uranium has a gamma line.
Okay.
Has a
All
couple of
right.
gamma lines, in fact. It's
Okay.
good.
So we'll have a look at that.
Yeah, no, there's gamma.
Okay. Hang on, just
How big? How big is the source? Is it a small piece?
yeah, it's just a small piece. It's maybe the size of a walnut.
Yeah,
So-
yeah, yeah. No, I mean, if you hold it up to the GM tube, it should count. And
Oh, oh, the GM tube was going crazy.
yeah,
The radio code, like hitting about point 0.3, yeah, about 0.35. Let me see. What was I writing down here? What a mess of.
yeah. Well, if you put some plastic in front of the window of the GM, it'll keep counting, and that's the gamma.
Yeah, yeah,
That's
exactly.
true.
Yeah.
It's true. Okay.
That's an easy one.
Yeah, it is. Well, I mean, there's plastic all around
Yeah.
the scintillator crystal.
Right. Or
Uh,
likewise, take the plastic away, and you'll see the count rate go up.
right, right, right.
Sure.
Okay,
And that's the
so
beta.
yeah, so with I was getting the Zen was clocking in at about 0.59 microsieverts per hour. The radio code about 0.65. Yeah, so uh and obviously I couldn't count. I don't have the means of counting what's coming out of my scintillator yet. Just because the microcontroller has some built-in analog comparators, so I can actually do a level comparison, as well as the analog to digital converter. But the data sheet is about 1,000 pages, so
Yeah.
how to program the stupid thing.
Yeah.
So I mean, it's very sophisticated. It's one of those things, like you want flexibility, you got complexity.
Yeah. So I just Googled pitch blende. It's
Yeah,
a primary mineral ore of uranium containing 50 to 80% of that element.
yeah,
So it's got all the daughters.
yeah. Okay, all right. So, um, all right. Anyway, so uh, yeah. Oh, well, yeah. I've got a big chunk of plastic. I can just, like just a cutting board, and just put it in the way and see what
Uh,
happens.
Louis, I was thinking that can you in the RAD code can you find a place where you can get the poles out in on the schematic? Just probe with a probe and find out to see if the pulse comes out to see how noisy that is. So you have a comparison.
Oh, I see. Just yeah,
Yeah,
uh,
maybe they're just noisy. I
yeah.
mean,
Well,
we don't know.
if you look at I mean, the whole arrangement, I've got this little circuit board sitting there. I've got a computer over here, right? I've got the oscilloscope. It generates its own noise,
That's
right?
true.
There's a,
Yeah.
I mean, I've turned off everything, and the noise is still there, right? I obviously can't turn off the computer or the oscilloscope, then I can't see the noise,
That's
right?
true.
It's like I want to stand alone. Give me my old tech. I want it. Yeah. So, uh, unfortunately, those things are even they're not cheap. So, anyway,
No, but
so
there are compromises. I mean,
yeah.
the
So,
the Rickles are not so bad. I mean, I
yeah,
have
true.
one and they're quite good
Yeah,
and not expensive. Let's say this way.
yeah. Okay.
Or
Anyway, coming
you
back
can
to
you can ask Alan to duplicate your work and he can check. He has a very good scope.
okay. Uh, anyway, so you're asking about the plastic parts. So okay, so this is the actual circuit board. Now, I'm not too sure we're going to be able to
Yeah, I can see that. Yeah.
okay, so
It's a 4-layer or 2-layer?
2 layers.
No, why didn't you make 4 with 2 grounds in the middle? That's
The,
safe.
well, the entire back is one big ground plane. There's no traces on the back.
I see. Oh yeah, I can see that. Yeah.
Yeah. And so all the traces are on the front, right? And obviously in the center is the pad for the SIPM. And the two, here I got a little mock-up here of you can see
I
there's
see.
the temperature sensor, a resistor, and a capacitor, and that's it. So the circuit board, let me see if I can pull this out. No. Oh yeah, here it is. So the circuit board actually sits in a little carrier.
Oh yeah, I
Right?
see.
The little tub. And the hood
It's like
sits on
that. Yeah,
top.
yeah.
So you can see that the hood fits right over top of the carrier.
Mm,
So, and then that is up against the circuit board. So there's no light coming in through here.
that's true.
All right. Yesterday I was using nylon screws, and I'm just like, why did I get nylon screws? The natural color, to let the light in. So I've got some hockey tape wrapped around, and on the bottom, covering the bottom of the screws, the nuts, is more hockey tape.
And
So
that helped, or no?
it was one of those things. It wasn't like, okay, let's try this, like the one at a time kind of careful experiments. It's just like, okay, let's just reduce
To
everything,
everything.
right? Because I've got some screws on order, like the same size screws, except they're metal. I don't know why. The brain cramp. So I've got those on order. They'll come in sometime this week, and I can replace them and get rid of the hockey tape. So
And
as
the
far as
wrapping, the wrapping for the crystal, what did you use for that?
the Teflon thread tape,
Okay.
yeah, just wrapped it a bunch of times and to
And
hold it
no
down.
no aluminum around it?
No aluminum.
Okay.
No. The that hood is printed. It's like 100% fill, right? And there's about there's about 2 millimeters of wall thickness, and it's black. So like and doing what I can.
No. We have to figure out how it works. I have no idea how to make them. So
Yeah,
let's see.
it could
That's why
be.
I talked to Steve too, and I think we should get Mihai
Oh,
to give
absolutely,
some
absolutely.
feedback. I mean,
Yeah,
he's the guy who's supposed to know these kind of things
yeah.
because he's
Oh,
been experimenting for years.
yeah. There's also another outfit. They uh, they published this thing called the Theramino, and what it is, it's using a Sound Blaster sound card. So they use a
Ah, yeah,
photo
can imagine it.
photomultiplier tube, sodium, like, well, actually, they could use any photomultiplier tube probe. They digitize with a sound card at 192 kilohertz, and then do everything
Software, yeah.
everything in software. And they claim that from fiddling and faddling and doing some filtering and stuff like that, they can actually narrow the pulse by 1 or 2%. So the FW half max. Yeah. They can actually narrow it down in software, which is, I mean, it's all published. It's all open source. Just look up Theramino, right? Like, as in
Let me know.
I don't know why they call it that. I mean, a theremin is one of those weird instruments that you wave your hands at it.
Yes.
But anyway, So that's where it stands.
Okay,
I'm just
but
gonna.
it's great to see your progress, and also very nice that you shared it with us.
Oh yeah, yeah. So I guess at some point I'm gonna have to figure out how to use a plastic detector. Well, actually, the actual scintillator itself, the crystal or the plastic, that that's the biggest cost, right?
Mm.
So and if you buy them in in onesies, just they're ridiculously expensive because the shipping costs or the
Mm.
it's like, well, we're going to sell you one for $100, but if you buy 10,000, well then we can talk. And it's like like Luxium, which is the formerly Saint-Gobain crystals, and they've actually been bought out yet again by some conglomerate. They basically told me like, well, our minimum order is $3,000. It's like, all right,
Mm.
just
But if you want, can ask my Japanese friend. I mean,
yeah, yeah,
the
please. If you like some was it PVT it's toluene loaded.
I think
Uh,
so.
yeah, so whatever. Some some organic some organic thing. Uh, but yeah, you can ask. But it's also going to be bigger, which means that
Mm.
now uh, with these photomultiplier tubes, the front area, if you look at like a picture of it, is nice and big, so you can put a great big chunk of plastic in front, and it fits. Where these uh, semiconductors, right? The biggest is 6 by 6
Mm.
millimeters, right? And that's what I have sitting under a 10 millimeter square uh,
Sure.
uh, uh, photomultiplier, right? Silicon chip. So,
No,
do we
but
have an array?
you can also make an array of those.
Yeah,
A
but they're
few.
expensive now.
Yeah, that's true.
Yeah, so it's one of those things. It's like it'll never be perfect.
That's true.
So anyway,
Okay,
that's
and
where it
we have
stands.
about 5 minutes. I just want to let you know that two things I already with Steve I talked about that
Hmm.
there is a possibility of workshops in a workshop in Lithuania from Safecast,
Oh, very good.
and because I met a person from Lithuania and she's teaching on different universities and different schools, and she said, okay, she will like liaison between the schools and Safecast.
Oh,
So
cool.
let's hope.
Yeah,
And probably Jelle will be happy because maybe Jelle can go there and meet his friends. So
yep,
that's good.
yep.
I hope
Oh,
so
very
for
good.
him.
Yeah. So
And the K-Geigie's are being rebuilt. The
the which
K-Geigie's
Geigies?
are K-Geigie's. They are small L&D tubes,
Yeah.
and they have an eye rover and a
Hmm.
click and an M5 stick or the M5 stack
Right.
to display it, the data. It's for kids to build it, and it's very simple with a breadboard and
Oh
some
yeah. Okay.
wires.
Cool.
You should see.
Oh,
It's
very
an
good.
educational thing. We did workshop with them for children. It's very simple.
Maybe maybe that's my low cost detector
Oh,
for in the
yeah,
house.
sure. It's very low cost. It's an eye rover, but you can use a safe pulse.
Yeah.
And if you run when you're really cheap, I can give you. I mean, I can give you the price we normally get for. Let's say the way we buy them. I think that we get down to $60, $16 these days
So for what
for an safe pulse.
for the safe pulse? Yes. The how
So
about the LNDs?
LEDs they go for $40, I think.
Oh, okay, not
No,
bad.
not that much, but they are about 3 times less sensitive as the big pancakes.
Yep. Yes.
They're very
So
reliable. We have them together with in the point cast. We have those for the gamma and
yeah.
the big the pancake for the alpha beta.
Oh, okay. So,
That's a very cheap solution and surely workable, very easy.
Yeah, I mean, maybe I might make that as a side project and show it around.
Hmm. I think Alan also made an bGeigieZ from that. That's the first bGeigieZ we made, from the small tube and an iRover, and then a
Right.
network card with an Arduino on it.
Okay, I'm gonna look into that. So
That I think you can build it for maybe $80 or something like that.
yeah, yeah. Well, especially if you 3D print the case.
Yeah, that's true.
Yep, yep. So, all right.
But don't print yourself. Let it be printed. It's much cheaper.
Yeah, I know. Just send it off somewhere. There's
Send it up.
yeah. Well, a friend of mine who does a lot of 3D printing, he's basically made a mock-up of the if you look at a hospital bed, right, for like for the in behind the bed, there's a big panel with the oxygen and the plugins
Mhm.
and all that. He's actually made a mock-up like that for teaching, right?
Ah, interesting.
For teaching clinics, like in the at the college. And he's found a 3D print shop in Winnipeg that just doing superb work. So avoid all the hassle of cross border and so
True.
so uh, so I'm going to talk to them. Uh, so yeah,
Yeah.
good idea. So what? So let me just write down. bGeigieZ, you said?
The bGeigieZ.
K. Oh, for kids.
Kids, yeah. I will dump. I will give you a URL. It's a GitHub thing from it too. And we
Okay.
did workshop also with a virtual breadboard, so
Yeah.
they could do. I could see what they were doing, so they could do on the breadboard in
Yeah.
the. They could show what they were doing. I could see real time if they were doing it correctly, and it was quite
Oh, cool.
interesting workshop we did. That was maybe 6 years ago, something like that. 5, 6
Mhm.
years ago we did that.
Good idea. Yes. Thank you.
Mhm.
Oh, and any update on uh, fixing that problem with the Zen that not reconnecting to the network?
Did you try the latest version?
I have the latest, is it 4.3.2? Because
Hmm.
you did a
Yeah.
commit, then you backed it out. So I'm at that level where at the back out, and the screensaver works, but it still loses
Still
its
loses.
networking. Yeah. So I think the big problem was a 3-second delay, like delay
Hmm.
3000. That's so